Pascal's triangle is a geometric arrangement of a number pattern. It was named after Blaise Pascal, a famous French philosopher and mathematician. Pascal did not develop the triangle. Pascal's triangle was first developed by the Chinese. Pascal, however, was the first person to discover the importance of all the patterns it contained. To build Pascal's triangle, we would start with a 1 on top. This will be called row 0. The next row, which is row 1, will contain 2 more 1s. These 1s were found by adding 0 plus 1 for the first one, and 1 plus 0 for the second one. In row 2, we would do the same thing. 0 plus 1 gives us 1, 1 plus 1 gives us 2, 1 plus 0 gives us 1. Row 3 would be 0 plus 1 gives us 1, 1 plus 2 gives us 3, 2 plus 1 gives us 3, and 1 plus 0 gives us 1. If we continue this, we would get 1, 4, 6, 4, and 1 in row 4, 1, 5, 10, 10, 5, and 1 in row 5, and 1, 6, 15, 20, 15, 6, and 1 in row 6. The way Pascal's triangle is constructed allows many patterns to arise within. During this presentation, we will investigate a few of the sums of the rows is the first pattern we will look at. The sum of any row can be found by using 2 to the nth power when n equals the row number. Examples are 2 to the 0 equals 1. As we can see in row 0, the sum is 1. 2 to the first power equals 2. As we can see in row 1, 1 plus 1 gives us 2. 2 squared would give us 4. As we can see in the second row, 1 plus 2 plus 1 also gives us 4. And in row 3, we would have 2 cubed gives us 8. And we would have 1 plus 3 plus 3 plus 1 gives us 8. The next pattern we will look at is the prime number pattern. If the first element in a row is prime, remember that each row starts with element 0, then all the other numbers in that row, excluding the 1s, are divisible by the first element. An example of this would be row 7. The first element in row 7 is 7, which is a prime number. We can see that 21, 35, and 7 are all divisible. The next pattern we will look at is the hockey stick pattern. If a diagonal of numbers starting at 1 is selected, then the sum of the numbers will equal the number below the last number in the diagonal. An example of this would be if we started at the 1 in row 1 and ended at the 4 in row 4. 1 plus 2 plus 3 plus 4 equals 10. As you can see, the number below the 4 is 10. Another example would be if we start at the 1 in row 7 and went to the 8 in row 8. 1 plus 8 equals 9. 9 is the number under 8. This pattern will work with any diagonal starting at 1. Magic 11 is the next pattern we will look at. If a row is made into a single number, carrying over from the right side when an element has more than one digit, that number can be found using 11 to the nth power when n is the row number. In row 0, we can see that there's only one 1 there. So the multi-digit number would be 1. 11 to the 0 power is 1. In row 1, we would have 11 to the first power. We have 2 1s in the actual row, so when we combine them together, we have an 11. 11 to the first power is 11. In the second row, we have 1, 2, and 1. When we combine them together, we get 121. 11 squared equals 121. In rows 3 and 4, we would do the same thing just by combining the numbers together. But as soon as we get to row 5, we start carrying over. To do this, we start with the right side. You would have 1, 5, 0, 1 plus 0 gives us 1, 1 plus 6, 1 plus 5 gives us 6, and then 1. So our whole number, our multi-digit number would be 161,051, which is 11 to the 5th power. The next thing we will look at is where the Fibonacci sequence lies in Pascal's triangle. The Fibonacci sequence can be found by by taking the sum of the numbers in diagonals. The first diagonal will go through the 1 in row 0, so we will get 1 as the first number. The second diagonal goes through 1 in row 1, which gives us another 1. The third diagonal goes through another 1 in row 1 and 1 in row 2. This would give us 2. The fourth diagonal will go through the 2 in row 2 and 1 in row 3. This would give us 3. The fifth diagonal will go through the 1 in row 2, the 3 in row 3, and the 1 in row 4. This would give us 5. So far we have 1, 1, 2, 3, and 5. These are the first 5 numbers of the Fibonacci sequence. If we were to continue this pattern, we would get more numbers in the Fibonacci sequence. The triangular numbers are one of the easier things to point out in Pascal's triangle. These can be found in the diagonal starting with the 1s in row 3. As we can see, we can start on the left side and move downward, or on the right side and move downward to get these numbers. Both sides work, and both sides list the triangular numbers. The next thing we will find in Pascal's triangle are the square numbers. These numbers can be found in the same diagonals as the triangular numbers. The square numbers would be 1, 4, 9, 16, 25, and 36, and then we continue on from there. The first square number is the 1 in row 2. To find the second square number, we add the 1 in row 2 and the 3 in row 3. This would give us 4. The third square number can be found by adding 3 and 6, which gives us 9. If we were to continue this pattern of adding, we would get the square numbers in order. As you can see, Pascal's triangle contains many different patterns. All the patterns of Pascal's triangle are infinite. This is because Pascal's triangle itself is infinite.